Okay, so here's the deal. Here's what we're talking about. We're talking about reference angles today, and our discussion started out with what? With us talking about how on earth you take the sine of 225. If 225 is more than a whole triangle, right? And so we got to this point. We said, well, first let's try and graph 225. 225 drops us off in that third quadrant. True? Now, sine, cosine, tan, this is all about trigonometry. So here's what some smart person did. They said, you know what? I'm going to draw a triangle in. Check that out. See that? Woo! Sneaky little guy. There's a triangle right there. And there's our triangle. And the key part to drawing this triangle is finding theta. Guess what theta is? It's going to be the, starts with an R. It's a radius. Wow. Whoa there. It's going to be the reference angle. The reference angle refers to the angles I showed you on that chart yesterday and asked you to memorize. How much is angle theta worth? Yeah, you do. Sure. How much is it? Here's the 180 marker, and there's 225. So how much did I have to go to get here? 45. So theta is 45. So in this case, theta equals 45 degrees. Now, what do you think? Is every single scenario going to have a reference angle of 45? Give me some other like small angles, acute angles from that chart yesterday. Like 30 and also 60. Okay. And what happened? And so let's talk about this a little bit. So in this case, if theta is 45, what's the sine of 45 degrees? The sine of 45 degrees is root 2 over 2. And somehow, when you punch sine 225 into your calculator, you got negative root 2 over 2, right? Why the negative? Well, it turns out tomorrow I'm going to show you that when you translate sine and cosine onto this grid, the sine of this angle is going to be the y-coordinate, and the cosine is going to be the x. So look, what is the y-coordinate in that third quadrant? Is it positive or is it negative? It's negative, and so that's why you get that negative popping up in the calculator. It's kind of telling you its approximate location. Anyway, just keep that in mind. Just keep that in mind. So remember the bow tie. What do I mean? So some people are like, well, how do you know how to draw the triangles in? The triangles can only be drawn in the shape of a bow tie, and not some weird offset modern bow tie. You know what I'm talking about? No, that classic bow tie. That classic bow tie that looks like this, as if you were going to the Oscars. That's the bow tie I'm talking about. Those are the only sets of triangles that you are allowed to use. Down with this? What do I mean? I mean, take a look at those set of triangles, and then take a look at the one on the board. Do you see it is one of them? You are not allowed to draw the triangles in like this. You know what I mean? That is ridiculous. Who wears a bow tie like that? You understand? You would look like a damn fool if you showed up to the prom with your bow tie like that. Your date should have adjusted you. Nope. Ladies, you're in charge. The bow tie needs to look like this. And so now somebody's going to ask me, why on earth are we learning this? Thanks, Troy. Good question. Good question. Troy, what do you know about a unit circle? Tell me some ideas that we've learned about. Radius is 1. What else? That's true. Where's it centered at? Good. And so what I'm going to tell you now is they lied to you way back in the day. Your brains actually weren't developed enough to understand this. Turns out the unit circle, watch this, is really built from those triangles. And in fact, everything you know about a circle, not everything, but there are a few things that you know about a circle that you don't know about a circle. I'm sorry. Like, how many sides does it have? Ooh, you do know this. Other people in the class were like, it's a shape with no sides. I'm like, no, that's completely untrue. What's up? It's actually a shape with infinitely many sides. What do I mean by this? I mean that the first set of shapes that get drawn are the triangles. And then we slowly build upwards, right? What's that shape called right there? And what comes after a pentagon? And then what? Do you see how they're slowly growing outwards, becoming more and more like a circle? Closer and closer and closer. Can you see it? Okay, good. Well, the circle was created from lots of triangles, and that's one reason why we learn about it in terms of trig. Like, watch this. All the points on the circle can be defined by lots of triangles, every one of them corresponding to a coordinate. See it? It's crazy, right? It's crazy. Check that out. All these points, everything. Yeah, yes. And what it means is that trigonometry no longer just applies to right triangles, right? They can apply to any curved, random shape that you can think about. I could tell you everything there is to know from the simple idea of trig. Pretty crazy, right? Pretty crazy. Let me just erase that because that looks nuts. Oh, sorry about that. So you ready for this? Okay. And the very last thing that I want you to write down is like, you see these angles in over here? I'm just going to label them up R1, R2, R3, and R4. Guess what those are going to be, since I labeled them with an R? Yeah, that's where our reference angles are located. They're not located up on top on the circle. They're always right over there. So R1, R2. Oh, R2. What's up, R2? R3 and R4 are possible reference angles. Who knew? Who knew all of this? I did. So here's what we're going to do today. We're going to do a few examples, and then I'm going to give you some examples for homework, and then we're calling it a day. You're going to be asked to draw the angle in standard position, identify the reference angle, write the problem using a positive acute angle, in other words, rewrite it in terms of the reference angle, and then find the exact value. That's crazy, right? It's a lot of work. Let's learn. Let's get our learning on. That's exactly what we're going to do. Get our learning on. Sure. Hold on one second. We still need some time. Do people still need time to take this down? You ready? So let's do this. Let's do this, man. Let's do this. Here's what I need you to do. I want you to draw that angle in standard position. Let's pick a person completely at random. Denise. Where does 225 drop me off? Got dropped off right where I wanted to be in that third quadrant. Nice. Love that. Love the third quadrant. It's nice and sunny down there. What? Because it's like Florida. Yep. There's my third quadrant. Now do me a favor. What are we asked to do? We got to draw. Do we have to find the reference angle? Of course we do. So guess what? We pretend like we are going to the prom or going to the Oscars, and we draw in our triangle right here, because that's part of the bow tie I'm wearing. There's the right angle. There's theta. How much is theta? Thank you. People in the other class were like, how did you find that? I know I just previously did it, which is also slightly shocking. Okay, how did I do that? Thank you. Exactly. You could do it lots of ways. The easiest of them all is to say that's 180, and to get to here, I needed 45 degrees more. Good Lord. Now, do me a favor. Type sine 225 into your calculator. Let me grab my calculator. I don't think I pushed it. So watch this now. Everybody make sure your calculator's in the right mode. That probably screwed a lot of people up on their quiz. Type in sine 225. Say to yourself, is that positive or negative? Thank you. So therefore, the sine of 225 is equal to the negative sine of the reference angle. That's all you do. It's the same thing. It's just the negative version of it. And how much is this? How much is the sine of negative 225? The sine of, sorry. How much is this, the negative sine of 45? Thank you. Negative sine 45. If you wanted to do it that way, it's the same thing as the sine of 225. And from memorizing our chart, who lives in the 7071? Rad 2 over 2, that weirdo, lives in the only area code with 4 digits. That's it. That's what we do. Is this easy? Honestly, this is cake. It's not bad. This is like the hardest part about your test. Yeah. So here you go. Do me a favor. Do the same thing. Same process. A, B, C, and D for cos 15. Cos 315. All right. Let's do this. Let's do this. Time to do this. Let's pick somebody completely and utterly at random, Sydney. Sydney, what quadrant did I just get dropped off in? A fourth one. Ooh, good question. How do I make that triangle? Well, I'm going to the prom. Which way is my bow tie going to sit? It's going to sit, basically you're always drawing it to the x-axis. It's going to sit this way, because that looks like part of the proper bow tie. There's my right angle. Here's theta. How much is theta? Theta is 45. It's not always going to be 45, but for these two problems it was. Now here's what you do. You literally type into your calculator cos 315 and determine whether it's positive or whether it's negative. Let's see. I don't believe you because sometimes you guys like to mess with me. Cos 315, it's a positive number. So it is literally equal to cos 45 degrees. Untrue. Oh, cos negative 45? That's fine. You are adjusting where the negative is. When it sits out in front, it means the whole thing is negative. When it sits right next to the degree amount, it means you moved the other direction. Okay. So in any event, what is 0.7071? Thank you. That's it. That's the final answer. But you could see how this would be damn near impossible if you don't have that chart memorized. People would be like, 7071, what are you talking about? Okay, so here's your classwork/homework for tonight. I want you to do that 6 times.